Hello! Not as exciting as the last time. This is my take 2, by the way. But anyway, we're going to be doing some more factoring today. And good news is that we don't have any new techniques to learn. Bad news is that it's slightly harder than the last section. One of the things that you will notice with all of the examples today is that there's going to be a number in front of the squared term, the quadratic term. So these are the type ax squared plus bx plus c. So if you look at your notes from the last lesson, the a was a 1. And because a was a 1, when you set up your grid, you always put 1 and 1 here. Well, that's not going to be the case anymore. But everything else is still true. You still have to find two numbers that multiply to get, in this case, 7. And on the left-hand side, we're going to put two numbers that multiply to get 6. And when I multiply the diagonals and add them together, I should add up to 23. So that part of the process is the same. So right now we're going to talk about some things that you could try. So for example, we know that the factors of 7 are 1 and 7 because the number 7 is a prime number, so it only has 2 factors. It'd be nice if I could get some proper colors here. Okay, so we have 1 and 7 there. And for factors of 6, it could be 1 and 6 or 2 and 3. So I'm going to start with 1 and 6. And then I'm going to try to do my multiplication on my diagonals. 1 times 7 is 7. And 6 times 1 is 6. And 7 plus 6 is 13. But we need a 23. So that doesn't quite work right. But you can actually do a couple of things. You could even say, well, okay, what if I put these in different positions? What if I move the 6 and the 1? Okay, then I'm going to go 6 times 7 is 42, and 1 times 1 is 1, and 42 plus 1 is 43. So in this case, neither one of those options work. So now I'm going to move on to another option, which is going to be, what if I try 2 and 3 instead of 1 and 6? So now I'm going to put 2 and 3 here, and this is still going to be 1 and 7, and I try it again. 7 times 2 is 14, 1 times 3 is 3, 14 plus 3 is 17, so still not there. Remember, I need to get 23. So then I'm going to try to reverse the 2 and the 3. So now I'm going to put 3 and 2, 1 and 7. 7 times 3 is 21, and 1 times 2 is 2, and 21 plus 2 is finally, yay, we get 23. So out of all of these trials, this is the one that works. Once I get my grid to work, as we did in the past, my factorization will be variable. So this time we have a number, it's not a 1. This will be 3n plus 1 and 2n plus 7. And that is the factorization. So again, it's the same grid format, but now you have to do more trial and error because now you're dealing with 2 numbers and not just 1 number like we did in the last lecture. So slightly harder. So right now we're going to have you do these examples. And then I'm going to go on and show you another example of what I just did. So the first example that we did, these are both positive and positive. So now what I'm going to show you is where it's negative, okay? So, but again, it's the same process. So 7 is a prime number, so really I only have one choice for the 7. The factors of 7 go on the left, and the only options are 1 and 7 because it's a prime number. But I do have options for 8. I could go 4 times 2. I could do 8 times 1. So I want to know which of those options is going to work. And I'm going to go with the big number because 26 is a pretty big number. So I'm going to try the 8 and the 1. I'm not saying it's going to work, but I'm just showing you how this process works. And I know that one of them has to be negative, so I'll try the 8 to be negative. And when I multiply 7 times negative 8, what is 7 times negative 8? Is it negative 56? I'm pretty sure it is.
Yes, I think so. Yep.
And then 1 times 1 is 1, and negative 56 plus 1 is negative 55. So that's way too big. So now I'm going to try, again, you can reverse the numbers. I'm going to go ahead and use my eraser here. What if I reverse them and put 1 and 8 instead? Then we're going to get 1 times 8 is 8, and 1 times 7 is 7. One of them has to be negative, but either way you're not going to get negative 26. So that doesn't work either. So then I'm going to try the 4 and the 2. So here's my 1 and 7. So those are the factors of 7. And I'm going to try 4 and 2. Okay? And I'm going to make the 4 negative. I don't know if it's going to work, but we'll try it. So when I multiply this diagonal, 1 times 2 is 2. 7 times negative 4 is negative 28. And yay, negative 28 plus 2 is negative 26. So that works because that's negative 20. So this is the right grid that I want. So then my variable is x, so it's going to be 1x minus 4, and then 7x plus 2. And that's my factorization. Alrighty? So now you can try these examples here. And then we only have one more example for you, because again, this is very similar to what we did last time. And that's this guy. So now we're getting all fancy schmancy. In this case, neither this number or that number are prime, which means we have all kinds of options. So let's see if I get lucky. For 20, we could use 5 and 4, 2 and 10. Why can't I think? 20 and 1. Is that it? That's about it, right? Factors of 20? Yeah. Okay. So then for 35, we could do 5 times 7. We can do 35 times 1. And that's probably it too, right? Yeah. Okay. So, I don't know. We wanted to add up to 80. Okay, it has to add up to 80. So we probably want some big numbers. But I'm going to go ahead and start with maybe 5 and 4 over here for the 20. And then maybe I'm going to go with 5 and 7. So I'm going to try these two, 5 and 4 and 5 and 7. So the 5 and 4 are the factors of 20, they go on the left. And 5 and 7 are the factors of 35, and they go on the right. And then when I try to do my diagonals, 4 times 5, this direction is 20. And 5 times 7 is 35. And that's 55, so not big enough. So then I'm going to try to flip these around. So maybe I'll do, leave the 5 and 4 how they are and flip the 7 and 5. See if that helps. And now I get 4 times 7 is 28. And 5 times 5 is 25. And I don't know what 28 and 25 is, but I know that it's not 80. It's not 80. So that doesn't work. So now, instead of using the 5 and, so the 5 and 7 didn't work. So now I'm going to use 35 and 1. But that just seems too big. I really don't think that the 35 and 1 is going to work. So I'm going to keep the 5 and 7. And I'm going to try to maybe flip these around and maybe make them into something different. So let's leave the 5 and 7. And let's put maybe 2 and 10. Like that. And see if that works. And I think we're onto something. This diagonal, 10 times 7 is 70. And 5 times 2 is 10. And 70 plus 10 is in fact 80. Yes, nice. So sometimes you have to kind of just try something and see if it works. But remember, you're never done until the grid all makes sense. Okay, you have to make sure that the diagonals add up correctly to the middle term. So before you claim that you're done. So once that happened, we got the 80 that we're looking for. Now it's going to be 10x plus 5. And then we have 2x plus 7. And believe it or not, even though we're pretty much done factoring here, this is not completely factored because 10 and 5 still have something in common. Both of those numbers are divisible by 5. So you can further factor out the 5 that both of these have. So the 5 goes out, and I'll put a 2x here because 5 times 2 is 10x, and then plus 1. And this is my complete factorization. I will also tell you that there was probably an easier way to do this problem now that I'm thinking about it, because if you look at the original problem, all of those numbers had a 5 in common, 35, 80, and 20. So you might have been able to pull out the 5 in the very beginning, and if you had done that, you would have had 4x squared plus 16. Is 16 times 5 80? Brandon?
No.
I'm pretty sure it is. So then 16x and then plus 7. So working with these smaller numbers, so instead of using the big numbers that we had over there, it might have been easier for us to factor this guy by putting the 7 would have been 1 and 7, and then we could have put the factors of 4, which are basically 2 and 2. So then we would have gotten 14 plus 2 is 16, and this would have worked as well, and that would have been 2x plus 1 and 2x plus 7, and then the 5 is out here, so you get the same exact answer. But again, that would have been easier if we would have factored out the 5 first. So my bad, I didn't do that, but either way we get the same answer. So I hope that you understand that this is the same process, but now it gets a little trickier trying to make all these numbers work out the way they're supposed to. So you can try this guy, and I will tell you that in this case, it would be wise for you to factor out, like, you know, all of these have a 2 in common, all of these have a 2 in common as well, and those also have a 2 in common. So it might be easier for you to do these problems if you factor out the 2 first. So once you've done these problems, you will have completed the lesson for today, and I will see you in class.